Hello, my name is Ken Welch, and I'm the co-founder of SimSolid. It's my pleasure today to introduce you to SimSolid and run you through some of the unique aspects of the product, as well as give you a demo and show you how it works. SimSolid is a unique product. It's a new paradigm for simulation. It is structural simulation, but it operates directly on the original unsimplified CAD assembly, fully featured CAD, and it doesn't create a mesh. It is a meshless method. The goal of SimSolid was to do this, but to do it in a way that gave meaningful, accurate simulation results in only seconds to minutes. SimSolid does this by eliminating the traditional FEA roadblocks of geometry, cleanup, simplification, and meshing. So think of many models. Meshing is easy until you have models that have both thick and thin or big and small features, or has a bunch of small geometry features like these small holes and bosses and things like that. Or you have odd face transitions or very small splinter surfaces. Common today is many of these facet or lattice type models. Those are also very problematic to mesh. But first and foremost, SimSolid is a way to accurately and quickly model small imperfections between parts in an assembly. So if you have small misalignments or gaps or overlaps, SimSolid can still create a valid connection and do the analysis. SimSolid uses unique adaptive solver technology. It doesn't just solve the equations one time, but it does multiple solution passes. And with each pass, it does error analysis, and then it does solution adaptation where it locally enriches the equations and resolves. This multiple pass method gives SimSolid both its speed and its accuracy. SimSolid is a fully featured structural solver. We try to find the balance between number of features and ease of use, but today SimSolid is both static and dynamic. It has both linear and nonlinear results. It does thermal and thermal stress. It includes inertial relief. It has all the connections you'd expect of a large assembly solver, things like bonded, separating, sliding, etc., and some that you might not expect, like bushings and elastic foundations. Now, I can't go over all the features of SimSolid today, but I will try to give you a broad overview and show you the workflow of how SimSolid operates. Okay, let's show you a demo of SimSolid. What I'll try to do today is do this analysis of this cube satellite, but I'll do it in a couple ways. I'll do two load cases, and then I'll also look at three design variations. And let's just see how fast we can get this done. When you start SimSolid for the first time, you'll see this welcome message. It's got a few, get you started hints and tips. But what I suggest you do is pick the green button at the bottom if you're a first-time user. And it'll take you to an Altair web page where you can download the Altair SimSolid Fast Start Training Guide. This is a PDF of maybe 50 or 60 pages, but it really has all the information that you need to get going. So I suggest you start there. Okay, let's just close this. Now, when you get to SimSolid for the first time, you have to open up a CAD file. You have a couple ways to do this. You can just, as standard products go, you can pick open and then go to the different CAD formats, CATIA, NX, or, Parasolid, SolidWorks, Creo and Pro-E, JT, Inventor, etc. So you can bring in geometry that way. Or you can get geometry through Cloud Access. And we have this little convenient cloud button here. Let's start there. So I'll pick Cloud. And I can connect any cloud data store that I have access to. In this case, it's Onshape. But let's go and grab my CubeSat here. And let's grab that first variant we discussed, variant A. I'll go for the cloud, grab the geometry. It'll load it. Now, a couple of things will happen. First thing it does is it loads the geometry and prompts you to create connections. You need to specify a couple things. First, the gap tolerance, the penetration tolerance, and then the resolution of the contact. So I'll just do this, and I say OK. and that'll create all the connections automatically. Now, the CubeSat model that we have is an assembly of, about 24 parts. And you notice these parts already have material properties assigned. Some of our CAD interfaces, including Onshape, will bring in both geometry and material properties. Not all, but you can, if you don't have your properties assigned, you can just go to Assembly, pick this button here, and you can pick the different materials that you want, as well as you can apply them to all parts in the assembly or just apply them to selected parts. I won't do that here. Okay, I have my assembly, I have all my connections created. So the next thing I need to do is do an analysis. I come up here and I pick what type of analysis: structural, linear, nonlinear, modal, dynamics, etc. Let's do initially a structural linear. And let's just constrain the base. And let's just pick maybe these 4 faces: 1, 2, 3, and 4. And let's just apply a simple unit load to one of the tops. So I just say unit load, I'll pick here. I'll make it maybe -1 Newton and Z. Okay. And now I'm done. I don't have to do any meshing, so I just hit this button to say analyze. Now, as it's analyzing, as I mentioned, it's an adaptive solver. So it solves it multiple times, 1, 2, 3, and gives you a result. So it's done. I can look at things like displacement magnitude. I maybe want to animate that. Maybe I speed it up a bit. And if I want to save any view for later reference, I just hit this little bookmark button here, and it'll save that image and animation into a bookmark, and I can go back to it later. So maybe I want to stop that. Let's look at maybe stresses. Okay, there are my stresses. Let's bookmark that. Okay, so I've done one analysis. Let's go back and do a second one. To do it, I could probably easiest, let's just copy the first. And if I double click, it'll edit any of the conditions here. So I'll double click that load. And let's just add the load over here instead and delete the first one there. Okay, and if I do that, I have a second load case with the unit load on this other spot on the model. Now I can run that in a similar way. And again, it's very fast. I think if you look at the speed, that took us for 24 parts, an adaptive solver, 3 passes, it was 2 seconds. So I can go back and look at my results. Now, as I pick the bookmark, you notice that what is bold is what's animating. So that's my first load case. If I want to see the second load case, just pick it here. And it'll automatically say, let's look at the load there. So I can go back and forth very quick. Same thing for stresses. There's the stresses there. There's the stresses there. Okay, that's great. Let's stop for that variant. But what happens now if I want to examine what happens when I change my model? Let's go back to the CAD source. And again, this could be any CAD source. I can go to Onshape, or I could go to NX or Creo or whatever. But I'll just go grab a different design variation. Let's get variant B. We'll open that. Now, a few things different will happen this time. First, it recognizes that as a design variation, and it copies it into a new design study. And then it copies down all the analysis boundary conditions that were defined above and make them all ready to go. So I have my 2 structural load cases on this new geometry. There's geometry 1, there's geometry 2. And to run geometry 2, let's just pick the root of the design study, and then picking it here will say run all analysis in that design study. So it's running this bold one here, that's analysis case 1, and then here it runs analysis case 2. Okay, so what I've done now is I've had 4 analyses completed, and they're all adaptive solutions, and they're for 2 completely separate geometry variations. So there's analysis 1, and if I want to go to analysis 2, just pick here. I can go back and forth again very quickly. So the idea is okay, I want to do a design variation and examine how the performance changes. There's, again, load case 1 or load case 2, etc. Well, that's great. Now let's maybe go back and do it a third time with the third design variant. So let's just stop this maybe. Go back here. And let's pick our third design variant, which is variant C. Open that. And again, although the geometry is completely different, it will bring in the geometry. It examines each part individually. It compares it with the previous iterations, and it will only copy it in if it is new geometry. So in effect, what we're doing is, although we have 3 different design variants in the model, the database stays smaller relatively because we only copy in the changed states. Now I can run this one as well the same way. Analysis 1, analysis 2. Okay, well, so there's, again, 1, there's 2, there's 3. All of that is, all that's done, off of the 3 separate CAD sources. Let's go back and do a couple more things. So let's say that, okay, that gives you the overall workflow. But let me show you a few other things you can do with the product. So first, let's look at, these were unit load cases. Maybe I don't want unit load cases. I want to combine those in some way. I can do structural superposition. And when I do that, it'll take, for that design study that I've selected, it'll look at all the analysis cases, and I can then just pick them and say I want to do a superposition, and I can scale each one. So instead of a 1 Newton load, let's do a 100 Newton load, and let's do it at both locations. I just solved that. It's extremely quick, and now I just come here and just look at my results there. So again, there's my display. In fact, I can just pick here and then go up here. So there's my 100 Newton load at the 2 locations. Here is my unit loads at 1 and unit load at 2. So it's very easy to do structural superposition, and that works with both structural analysis today and thermal analysis, if you have one. Okay, let's do one more thing. Let's do some dynamics. So I want to go and look at modal. Maybe let's solve for 20 modes. So I'll do a modal workbench. And in this modal workbench, first of all, I want to copy my fixed boundary condition at the bottom. So I can just say, pick here, I right click, and I say copy to modal. So now I have that boundary condition down there. And now I'll just solve my modal. So this is constrained at the base, and I'm looking for the 20 flexible modes. Again, it solves it adaptively, pass 1, pass 2, pass 3. And now what I can do is I can look at the mode shapes. Now I can do this in a couple of ways. I can just say, look at my modes, and I can animate them like you'd expect. And there's mode 1, and come up here and go down, mode 2, mode 3, etc. Or I can come here and look at modal participation, and I can just drag this up. Let's just make it off this side. Okay, I can look at my modes, I can look at my effective mass, and I can sort it by picking any column. And as I pick the columns, I can also show a histogram, etc. And if I want to change my mode, so I can just pick the mode here. So it's very quick to go between different mode shapes. Okay, I have my modes done. Let's now maybe close this. And let's do one more thing. Let's do a frequency response. So frequency response analysis, I have to reference a modal analysis. Since I only have one, it shows me that. It automatically links to it. I specify my frequency span and my modal damping. I'll just do 3% modal damping. I say it's okay. And now I have to specify where my loads are. So first of all, I'll look at my frequency function. I can make any function I want, point by point, or I can just go through some standard functions: triangular, rectangular, half sine, harmonic, etc. What I'll do is just grab a uniform. I just want to hit it and sweep it through all the frequencies. So I'll do a uniform frequency function like that. And then why don't we just hit it at the same place we did before? So let's just pick here. Let's do, again, the -1 Newton load on that part of the model. Okay, so to analyze that, we just pick here. And this dynamics analysis are very fast as well. And you notice I didn't specify the number of time steps or how many results I wanted and all that. It will calculate all the results on the fly. So in terms, all those types of complications are eliminated with dynamics and SimSolid. So to look at results, maybe I want to look at displacement Z. I can look at that. I can animate. I can pick an XY part. Let's say I just want to look at it there. And there is my sweep of frequency versus displacement. If I want to look at different points, I can do that. Just pick a different point and does that. Of course, I can look at it linear and log and etc. One more thing that I could do, though, and I think this is interesting, is SimSolid has at its latest release something called partial dynamic response. Now, if I pick a curve, just pick the curve right there, it'll give me all the modes here, and I can select which modes I want to contribute to the overall response. And I can sort it. So let's say I want to look at the contribution. The largest contribution here is this mode and this mode. Let's say I want to get rid of these modes right here. Let's say I want to get rid of these modes right here. I can just go select that, select here, and then I can say evaluate response. And what it's done is it used all the modes that I selected and it created a partial dynamic response. So you see, since I took out those modes, the partial response looks like that. So again, the idea with SimSolid is provide fast and accurate and as broad as possible results that you can use to quickly evaluate design change. So with that, I think I'll conclude the demo and make a few closing remarks. Okay, so that was the demo. Maybe just to summarize, what did we see? We saw the workflow for doing SimSolid. We showed how easy it was to do multiple analysis and multiple design variants. We did both static and we did modal, and we did dynamic. We did frequency response. We did partial dynamic response. We did low case superposition. We did all of that in the span of 5 or 6 minutes. So hopefully that gives you an idea of how SimSolid can be used and how you can benefit from using it. Before I stop, I would like to point out a few more places you can get information. You visit us on the web at altair.com/SimSolid. There's a lot of resources there. You can also go to our YouTube channel and see other videos like this. What I suggest you do, especially if you're a first-time user, is try SimSolid, but try it on real full-featured CAD geometry. Don't use your typical FEA simplified geometry. Don't merge the parts. Use all the parts as they're specified. So it actually solves better with full unmerged geometry. And what I would do is start small. Do a small assembly or maybe even a single part, and then work up to larger assemblies as you familiarize yourself with the product. Finally, if you want to compare it with your existing FEA solution, what's important to do is compare apples to apples. So don't compare shells or different boundary conditions or different type of connection conditions. When you compare it, make sure you're doing it with solid. SimSolid is only a solids-based solution, and make a similar comparison. I think what you'll find is that SimSolid will give you the same or even better results, but it'll do it in a fraction of the time. So with that, thank you for your attention, and I invite you to try SimSolid for yourselves.